So thank you everyone for joining. It's great to have you with us today. We're going to be speaking through application delivery in a cloud native world. We have Simon Michelson, who is head of our solutions engineering and architecture, who will be taking you through the topic. We're going to touch on concepts including cloud native, Docker Swarm, what it means for companies, where it fits into application delivery in the overall landscape, and really just what it means for you as a business. So Simon, I'm going to hand over to you and looking forward to the webinar.
Thank you, Gabby. Good morning, good afternoon, good evening to everyone, and thank you for joining us for this session today. And just before we go ahead and get started, Gabby, just making sure that you can hear me loud and clear and there are no audio issues?
No, absolutely perfect from my side.
Okay, great, excellent. So the topic for today is really to look at application delivery in a cloud-native world. And this is a topic that's been on our minds, I think, as IT professionals for quite a while. As we adopt cloud services, cloud computing, and new architectures, really. It presents new opportunities and it changes things and the way we've been thinking about systems, the way and the way we've been implementing them. So let's go ahead and get started. And really, before we kind of dive in, really define what cloud native means. And needless to say, working with many companies and solutions and vendors, everyone has a slightly different definition. But we'll go ahead and get started from the beginning, and then we'll kind of review key topics around cloud native applications and some of the challenges associated with delivering apps today in those types of environments, and how will we be able to harness all those capabilities that are at our disposal to improve upon the existing solutions we've been delivering for the past 20 to 30 years. And really, if we think about cloud native and what that term really means, this is not a binary definition. It's about really taking advantage of cloud and what cloud has to offer us as far as delivering business-facing applications, whether it's to our users, consumers, and the cloud provides a ton of resources that we can leverage. And really, the way we've been thinking about IT traditionally in a data center that was based on running physical servers, virtual machines, we've built the entire stack ourselves, where we overlaid multiple solutions for security, monitoring, performance, scalability, and of course the application logic, combine them all together to deliver a best-of-breed service. But in a cloud environment, if we take Amazon, Azure, Google Cloud Platform, DigitalOcean, and others, they provide many of those resources that we used to manage and deploy ourselves. So if we take at the most simplest example, if you will, running a simple web application with a database backend, that could be your company's website, that could be your SharePoint site, anything that is storing some content, whether it's metadata or actual files, and presenting a website to your users. So if we were to migrate this in a very simple way from our on-premise data center to a cloud like Amazon, we could simply copy and have one instance running our website and another instance running our database server as two virtual machine equivalents, if you will. That is more of what we call a lift and shift. We're simply lifting the infrastructure we had on-prem and we're copying and pasting it to a cloud platform. Now, this could be one way, of course, of facilitating that migration. But another approach could be to look at the different services provided by that particular cloud provider. And for instance, Amazon could give us the MySQL backend, the database, as a service, so as a relational database service. And we can simply leverage that directly from our website. So instead of having to, for instance, manage a dedicated instance running our database, we can get that as a service by the cloud provider. Now, what that means for us is that, of course, we benefit from all the features and functionality by having the cloud providers host it for us when it comes to uptime, availability, security patching, being able to scale this environment out, of course, to accommodate an uptick in demand, and of course the data protection aspect of your database, which could be very mission critical. So instead of architecting this yourself by managing storage and the data protection and the security patching of the server, you can get that as a service from the cloud provider. And this would be one step you could, of course, implement towards a more cloud native environment, where you would be leveraging a service provided by, or a resource provided by, that cloud provider. Now, if we take that even a step forward, of course, your application stack is much more sophisticated than just running a website and a database. And previously, you also had monitoring. You maybe had some logging capabilities, auditing capabilities as well. You may have had some automation built in, scripting to deploy that application on a hypervisor in your on-premise data center. All of these resources are again provided to us by those cloud computing platforms. And in the bottom example, I show a native monitoring service provided by Amazon, for instance, that will be responsible for capturing key performance indicators, health attributes from our website and our database to ensure that ensure the stability of the platform and identify any potential anomalies in traffic. So this would be another example where we could leverage the cloud and the resources that it has to offer us. But as you can see, this is not a binary definition of what cloud native means. There's definitely degrees of cloud native, and as we adopt more and more of the resources that are at our disposal, we can really harness and leverage those true benefits that the cloud has to offer us. So these are really the characteristics of what we identify as cloud native in the market, and every vendor or every solution has its own level of adoption of cloud native capabilities. Now, notice that throughout this description, I haven't even mentioned or started to discuss about open source technologies, about DevOps, about microservices, or even containers for that matter, which you would commonly hear those terms get associated with cloud native. And some people tend to, of course, assume that cloud native necessarily means containers or vice versa. These are all definitely tools and services we could leverage to deliver a more modern infrastructure to our users. But of course, all those capabilities need to be combined together in order to deliver a service. Now, we don't have to use all of them. We can, of course, implement a subset of them, and we can, of course, add them incrementally as we want to keep improving and enhancing our solutions as a business. So with that, if we take a look at what the opportunity is, so we've defined cloud native, and we understand that there are degrees of implementation, if you will. In terms of the benefits that it can really offer to us as organizations, one is, of course, continuity. One of the beautiful things about cloud is its resiliency and the uptime it can offer us. So especially when we look at running workloads on-prem, in the cloud, in multiple regions, maybe in multiple continents, the fact that we have the opportunity to introduce resilient services. If anything happens to on-premise workloads, cloud workloads in a given region, we can quickly implement disaster recovery to another region. Now, that said, that has to be architected in the cloud. It's easier said than done. However, the tools necessary are there, and a lot of the complexities we had to deal with when we built our own data centers are no longer applicable, because that's delivered to us as infrastructure virtually in the cloud. So it's a lot easier to implement those types of business continuity, leveraging the ubiquity of a cloud solution. Next is uptime and availability of our systems, and especially thinking about 5 nines or even beyond that for system uptime. Cloud again presents us with the automatic failover and transition between primary and secondary workloads. We run across multiple availability zones or regions that correspond to data centers, essentially. So if any workload becomes unavailable or unresponsive in a given data center, then they could be presented immediately in another one. And of course, availability is as we start to implement distributed applications that need to be consumed globally, not only in a specific region. So expanding our footprint to Asia-Pac, to Europe, to South Africa. So these are all, since those cloud providers have that presence in all those continents, it provides us with an easy way to expand and improve our availability overall. Next is, of course, performance and scale. Performance is especially key, and traditionally we had to commit and purchase certain servers with enough CPUs and RAM, and we tend to overspec things in order to be able to accommodate any future need for resources. And the fact is when it doesn't matter what you buy, you always find that you could have used maybe a little bit more. The reason is because requirements change over time. Business requirements tend to be more than what originally anticipated, and we need to be able to elastically accommodate that. And the fact that we can simply right-click on an instance and simply allocate additional resources is great, because then we can handle more traffic, more demand from our users and clients, and of course scale this out horizontally to be able to meet eventually the demand. And lastly, of course, is the cost-saving portion of it. Now that comes with an asterisk, of course. In a very lift and shift method, when we're copying resources from on-prem to cloud, the opportunities for cost improvements are more limited, as opposed if we were to really leverage the capabilities that are provided natively to us by that cloud provider. So, for example, if we take a look at an application that has a burst in traffic on the New Year's, so December 31st, but at the remaining of the year, the traffic is relatively low. So would it be so what would be more cost effective to implement is effectively to elastically scale that application on December 31st, but then scale back and scale down for the rest of the year. Overall, that will yield the best average cost for infrastructure, as opposed to having to allocate less and then potentially not meeting the demand on that particular day, or alternatively allocating a lot more resources than needed and then paying for a lot more infrastructure than you're actually using. So when we look at cloud native as an opportunity to save costs, we have to look at the capabilities and see if we're leveraging them in a certain way that enables that cost savings. Of course, the other option is if we are able to drive more value. For example, if cloud native improved our availability and uptime and business continuity, that would maybe be a good reason to pay as much or if not more to be able to provide that level of service. But otherwise, when implemented in the right manner, cloud native can help us also save significantly in our cost. In terms of technical benefits, and understanding that from a business standpoint there is value, but we also get excited about some of the things we could do as IT professionals to simplify how we're managing information systems. And specifically, cloud native provides us with ability to manage updates a lot easier than what they used to be. Traditionally, in many instances, deploying applications on premise would have required a downtime of some kind, whether it was minutes, hours, or sometimes even days, to upgrade a database, to simply update a web service. And In a cloud native environment, we are able to implement things such as rolling updates. We can gradually test an application on one node instead of 100. If it doesn't prove to be effective, we can always scale back and implement a previous version. We can continuously integrate new code. There's some companies out there that push about 1,000 changes to production every single day, and that's impressive. And overall, that's also alone in its own a business benefit, because once we can react quicker and be able to address client needs a lot faster, it has a direct impact on our ability to do business. So updates that are easy, updates that are pain-free is a huge technical benefit that can be implemented in a cloud-native environment. Second is, of course, scale. If we take a look at some container orchestration platforms, and we're going to dive into those in a little bit, they really changed the game in the way we think about scale. Traditionally, we had to implement additional VMs or maybe an auto-scaling group even. But when you think even in a container orchestration platform, it's as easy as to say, I want to scale my 5 containers to 50 containers. And all I have to do is simply execute a single command, and the orchestration system will take care of that for me. So that is really powerful, because scale was always a problem or a challenge for many vendors, many solutions. In those types of environments, the fact that we can quickly increase the number of instances and very easily has a dramatic impact on our execution. And then third is multi-tenancy. Typically, if you take a look at traditional architectures, they were very sensitive to running multiple workloads on the same virtual machine or the same operating system. In those new environments, we can multi-home or add multiple tenants within the same virtual or physical instance. By running multiple workloads, of course, this can help us from a cost-saving standpoint, but still maintaining that isolation at the software layer, but be able to do more with effectively less resources. And of course, there are additional benefits on the technical standpoint: stateless services, a better modularity between the components of your application, and lastly, when it comes to automation. And cloud presents so many tools and opportunity to automate business processes, starting from deployment to management to upgrades, and we can see a lot more companies adopting the DevOps the paradigm shift, with really thinking about infrastructure as code. Infrastructure needs to be consistent and be deployed quickly to any environment, if you will. So that presents a great benefit, and kind of goes hand in hand with how cloud native is seen as an opportunity for improvement. But at the same time, we have to weigh the business and technical benefits. If you speak to a technical person, architecture perfection is really priority number one. But if you discuss with a business leader, then of course those key aspects on the left then become more prominent. Now there are different types of technologies and services that we can leverage, but I think this is a good quote from Gartner: is not to confuse the architecture perfection with the actual value provided by that architecture. So we hear a lot of conversations about microservices in the market, where essentially every piece or every component or service in your application has its own state, and that state is not shared with any other part in the architecture. But that's easier said than done, although that provides that perfect separation between resources. But at the same time, we have to recognize that it can create a little bit of a chaos, because if you're looking at systems that were highly distributed and also separated into multiple services, it could be very cumbersome or difficult to be able to manage them and really get to reconcile everything into one clear picture. So That's why Gartner has also proposed the term mini services, which is a construct that's a little bit bigger than a microservice. It can share state between multiple different services, but at the same time, maybe provides a good balance, a good compromise between technical drivers and architecture perfection, and of course the actual value it ends up bringing to the business at the end of the day. So this would be our recommendation to really weigh the benefits, the pros and cons of every architecture and technical decision. Is always go back to those business drivers and see whether we can meet them, and then build upon that, right? So the beauty about cloud native is that easy updatability and continuous integration. And I mentioned that example of a vendor that's pushing 1,000 changes to production a day. So start with an MVP, and of course keep updating and improving incrementally your architecture by introducing additional services and driving more value. Okay. Now, if we take a look at a little bit at the landscape and the types of services that we can leverage. Now, but before we kind of dive in, of course, this is a very basic view or limited view to the vendors and solutions that exist out there. There are plenty of others segments in the cloud native market, as well as solutions that help address each category. So very extensive, and in terms of broad offering, it has a lot of capabilities to offer. Sometimes even could be too much for one person to really accommodate and understand the entire stack, but definitely very interesting. Now, if we take a look at specifically on the top left, Kubernetes services, the cloud providers, companies like Amazon, Google, Azure, DigitalOcean, they provide a managed Kubernetes service. They called AKS, stands for Azure Kubernetes Service. GKE stands for Google Kubernetes Engine. And they essentially provide for the ability for you to deploy clusters and run your services on those managed infrastructures. Now, the actual container orchestration systems that are available are solutions like Kubernetes, Docker Swarm, HashiCorp, Nomad. These are all solutions, and others, of course, that specialize in deploying and scaling and managing containerized applications. Now, when I say containerized applications, the technologies that I'm referring to are at the bottom. Containers like Docker, Containerd, CoreOS, or even the Apache project called Mesos. There are, of course, additional other solutions, but Kubernetes is essentially a portable and extensible open source platform for managing those workloads. It facilitates what's called a declarative configuration and automation for running services. And it has a very large and, of course, rapidly growing ecosystem. And many vendors are partnering with Kubernetes to provide more features and functionality. And if we take a look at the service mesh category, and this is somewhat of a new or still modern concept that we're still trying to really understand its benefits and how we'll be able to leverage it to its fullest potential. A service mesh is our way of controlling different parts of an application and how they share data among each other. So unlike other systems for managing this communication, a service mesh is a dedicated infrastructure that dedicated infrastructure layer that's built right into the app. This visible infrastructure layer can document how well different parts of the app interact with each other. So if we take just one example, for instance, where we have a website like Netflix, and we have a streaming service, but then we also have maybe a recommendations engine. So at any point in time, the main website for movie selection could be communicating with the streaming service, and then with the recommendations engine, and then the recommendations engine could also be communicating with both and also with the database of a catalog of all the available movies. And they keep interacting with each other. So it sounds like in a cloud native environment, we have a scenario where there are many workloads that are talking to each other at any point in time, because in their nature of being distributed. And since they're broken down this way, it presents an opportunity, of course, to add a lot of security, but also manage the networking and balancing of traffic, not only externally to your network, but also as network travels between the quarters of your Kubernetes clusters. So at a high level, let me do this. When we take a look at the service mesh part of the industry, it provides us with a new way of essentially implementing various different types of solutions. And given that it's a new and modern concept, it sometimes could be hard to navigate. And it may be still considered as a modern approach, and the industry has yet to define best practices around it to really define how it should be leveraged. But again, we're going to cover in a little bit more detail the opportunities that we have to leverage service mesh. But before we do that, let's go ahead and really define the basic concepts of what a Kubernetes cluster is. And again, this is one of the examples of a container orchestration platform. And if we take a look at a simple cluster, it's comprised of what we call a master node. First of all, a master node manages the individual nodes that are a part of this Kubernetes cluster, and it schedules the deployment and scaling of the individual containerized applications. If we take a look at nodes, nodes are constructs. These are virtual or physical machines that are part of a cluster. We can deploy as many nodes as needed, and nodes are, since they're a virtual or physical machine, they're associated with an IP address. So they have a defined network segment, and in this example, 192.168. Next, we have our deployment. A deployment really is a template or a configuration that defines how an application or a workload should run on the individual nodes. So in our case, our app is called App A, and we would like to deploy 3 instances of that app. And the construct that Kubernetes offers us to run services or execution units is called a pod. A pod is essentially a logical construct that groups one or more containers. It has its own IP address, and it provides some shared infrastructure for the containers that are running within. But pods are mortal. Pods have a life cycle, and if anything happens to one of the nodes in the cluster, the pods can then be spawned and launched on a different node. Essentially, when you deploy a workload into Kubernetes, you define how many copies of it you would like to have at any point in time, and the cluster will manage that for you. And this is one of the benefits of leveraging this environment is if anything happens to one of my instances here, then another instance is going to be launched on a different node to make sure we're able to keep that minimum. And then the third component is what we call a service. A service is our way of externalizing a workload. Since Kubernetes runs everything in a private network, those IP segments you can see with 10.10, 10.0.0, this is an internal IP segment that is only accessible within the cluster. Now, needless to say, to be able to provide an application externally, we need to expose that over a designated IP and a port. So in this case, we've created 2 services on a different network segment, 10.0.1.1 on a different port. And then we can use those IP addresses to, of course, provide access for external users onto our application. So think of this example as maybe a calculator website where we provide an online calculator that you can type in, of course, basic arithmetic and calculate the output. So we have 3 instances then at any point in time, and if anything happens to one of them, we're going to be able to launch more. But even in this basic example, we have about 8 IPs, 3 for each of the nodes, 3 for each of the pods, and then we have also 2 services. And we have 3 different segments. We have a segment for the internal network for the pods, we have one for the services, and then we have another one for the actual nodes. Now, the IP that's accessible externally is really the node IP address, because the node is the construct that is managed by that managed Kubernetes cluster running in Amazon or Azure or even on-prem. So given this in mind, this could also quite help us understand that routing, networking within a cloud-native environment alone could be a challenge, and that we need to address. So if we take a deeper look into what we call services, and again, a service is a construct that we use to externalize services running, to externalize pods running in a Kubernetes cluster. There are 4 different types of services that we can allocate. One is called a cluster IP. That only enables traffic for within the cluster, if between the pods, and if we need to have users workloads accessing each other. It does not provide any type of external access. Second is called node port, and this is what we used in the previous example in the diagram, where you have workloads running on port X, and we want to publish them on a different IP on a designated port. So node port provides us with that function. It essentially provides a network address translation, and for workloads that now will be reachable outside of our cluster. The third option, and it's marked with an asterisk, is called a load balancer. This capability is only supported in specific environments, and specifically in cloud platforms where there is a load balancer construct. So in Amazon, Azure, Google, DigitalOcean, and by requesting a load balancer in the Kubernetes cluster, then the cluster will then automatically allocate that component externally in your environment. But of course, if you're running in an on-premise environment, you don't have that ability, that integration, and you would have to essentially implement it yourself. And then lastly, external name is the 4th option, where you can use, instead of load balancing, simply replying back to a service with a different common name. So if I'm requesting service X, I'm going to get a reply back and say, here's the address of service X, go and find it. So these are the 4 different options. So really, when we kind of focus on the different options that we have to our disposal to really manage traffic coming into our cluster from the outside world, there's really one option, which is the load balancer. Now, if we take a look at some of the challenges that are associated with that, of course, one option we have is to simply allocate as many public IPs as we want for each of our nodes. So in the previous example, we had 3 of them. So imagine we would have to allocate 3 public IPs, but that alone could be challenging. Public IPs tend to be limited. We cannot allocate as many as we want, and also it could be quite cumbersome to manage if we have a 10-node environment or even a 20, 30-node environment for those more complex environments for cloud-native deployments. So public IPs, although can provide a suitable solution, can be difficult to manage. A load balancer capability is again limited to a set of cloud providers, and but what you eventually find in those types of situations is that it's difficult to predict the cost. They're not so cost-effective as far as handling high volumes of traffic or even traffic bursts. The way those solutions are designed, if you take Microsoft Azure, for example, they charge per rule evaluation, essentially, and the amount of data that's being processed that's traveling the load balancer. If we take a look at DigitalOcean, for example, their load balancer offering is currently limited to about 10,000 connections, and essentially this could present an upper ceiling for many applications, and understanding that in some situations you would need to scale beyond that, and in that case you would have to look for an alternative load balancer capability. And if we take a look at the Amazon example, what happens there is essentially Amazon monitors a set of attributes that makes it really difficult for us to sometimes predict the cost, as well as charging based on the load balancer uptime. So if we have the load balancer running and really not managing a lot of traffic, we're still paying a fixed cost for that service to be online. So when you combine all of those, the fact that it's hard to predict the cost, as well as sometimes even scale beyond a certain number of connections, that could present, of course, a challenge for us. But in an on-premise environment, since we don't have the integration altogether, we also have to look for a different solution. So our recommendation in this case is really to assess the spectrum of solutions that are available, both natively provided by the Kubernetes cluster, such as the ones we've discussed around cluster IP, node port, external name, and of course the load balancer integration, as well as of course other alternatives that are not native to Kubernetes, but they provide that balance between cost effectiveness and of course the feature and functionality needed to support that amount of connections and activity to your website. Now, if we take a look a little bit beyond that, beyond managing traffic that's external coming into our clusters, since applications tend to be distributed in those types of environments, we could also have situations where we have to manage how traffic is being distributed between the individual functions or pods that we have running in our cluster. So again, if we go back to the service mesh example, where we have a website, we have a recommendations engine, we have a database with all the movies, and we have a streaming service. Those applications tend to be broken to individual components in this manner, and each service is really performing a specific business function. And in order to execute this function, one might need to request data from several other services. But if some get overloaded with requests, then we would have to, of course, be able to address that by routing the traffic to another instance in that case, to optimize all those moving parts to have them work together. Cloud native is about multiple different services and components working together as one. So this may introduce some of course more complexity that's sometimes even counter to our business objectives, and it could be still considered as a very modern approach, but sometimes reconciling everything together might be a little bit difficult. So in terms of the options we have to really, or strategies to balance and route traffic with access control within a cluster, we can leverage some of the native capabilities provided to us by Kubernetes, for instance. One of them is called an ingress controller. It provides basic load balancing capabilities. It offers some TLS termination, and of course routing based on name-based virtual hosting. Next is, of course, we can leverage service mesh solutions. So products such as Istio, Linkerd, and Consul. Again, very modern in terms of the suite of capabilities that they offer, and they present an architectural change that we have to learn and study, and of course implement, which again might be too big of a leap sometimes to implement in terms of migrating from an existing application. But they do offer what's called a sidecar proxy, or an agent-based solution that is running beside the containers and providing those key functions for TLS termination, load balancing, and many, many more. And they can even offer us sometimes the granularity between restricting access between multiple processes between different pods. So the level of granularity that they can offer is pretty high, but again, it needs to be leveraged in a certain manner that is manageable going forward. The third option is, of course, to also look at incorporating a very lightweight micro application delivery controller solution, specifically to address the load balancing and of course the security aspect of the traffic. So web application firewalls or web API protection and load balancing can provide us with layer 4 and layer 7 traffic management, and they can also be deployed as a very lightweight binary in a cloud native environment next to your containers, and then provide, of course, that security and networking stack for traffic that is traveling between the individual pods of a cluster. So routing and access control is a huge topic, and we haven't even touched on other aspects of cloud native, performance, caching, and security. Each and every part of this webinar could be broken down into its own dedicated chapter, and we can spend quite a bit of time talking about security in containers, routing, and of course DevOps and visibility. But the purpose of this is really to give you kind of a background or a listing of the different functionalities that or options that you have at your disposal, and we can help, of course, offer some guidance around how to leverage them in what manners. So next is, if we take a look at network security, and specifically the layers of protection that we can look at. Of course, traditionally, if we take a look at how traffic has been managed in an on-premise data center, we had, of course, security implemented at the gate before traffic was coming in, and within the network, usually applications could really talk or address anything that was accessible to them within their network segment. That protection was done at layer 3, of course, in the IP and ports, restricting specific countries, and of course, defining rules, what source can speak to what target. Next is, we also saw many zero trust based solutions that offer security controls in a cloud native environment that are, of course, focusing on layer 3 protection, again based on IPs and ports. Layer 4 is, of course, on the TCP stack, and doing implementing protection at the transport layer of whether it's a TCP or UDP type of protocol. And then lastly, many applications still tend to be web-centric, so or web API, providing HTTP or HTTPS like access, and as a result, they're vulnerable, could be vulnerable to security risks like SQL injection, remote code execution, cross-site scripting, and so on. So traffic inspection or protection against bots and vulnerability scanners is still very important, very relevant, even in a cloud-native environment. And when we take a look at all these different layers, we also have the opportunity of implementing them, but in 2 different places. One is, of course, filtering 95% of the traffic that is considered, well, that is not considered, let's say, legitimate before it even arrives to our cluster. So if we take a look at, so one protection point would be as data is arriving into our cluster. But then second is, how do we protect data traveling between individual pods running in a Kubernetes cluster? So implementing both would, of course, be or overlaying the in-cluster security on top of the external security would be the desired, most optimal type of approach. And of course, each of the individual layers. But at the same time, again, we have to weigh the business and the technical priorities together to identify what would be the kind of the desired approach going forward. Now, if we take a look at traffic, of course, traveling between the individual pods in a cluster, we can, of course, implement layer 3 to layer 7 but then we could also leverage service mesh solutions to really get even more granular and define that certain processes cannot communicate with other processes running on different pods. So there's certainly an opportunity to implement a very secure solution today and then keep improving and adding additional capabilities as we go. Next is, of course, automation. And when we think about cloud native workloads, automation kind of like goes hand in hand with that. And specifically, the three topics that are of interest to us as IT professionals is automation. And surrounding automation, we need to look at service discovery, since workloads are dynamic and could be running now and could be turned off and turned on later. We want to be able to discover workloads in an automatic fashion, whether it's based on DNS, whether it's based on labels, whether it's based on tags implemented in cloud computing platforms, or even sometimes image identifiers. So these are some of the key priorities, of course. But then if we take a look at auto-scaling, scaling the amount of traffic that we're able to handle at the front end before traffic comes into our cluster, but then also scaling the in-cluster traffic communication between the individual components and individual services. And then lastly, we want to be able to deploy this entire infrastructure as code, have a consistent configuration that's repeatable, that's easy to replicate, and has a very consistent performance across multiple platforms. So in this example, what we can see here on the screen is, for instance, the Nova product, the Nova platform, worker ADC, essentially deployed as a Kubernetes YAML template. So in this case, to be able to spin up an application delivery controller or a micro WAF function, that's all we need, is to simply express everything in a very simple configuration file. And as traffic starts to peak or uptick, we'll be able to deploy those on the fly and automatically pull the desired configuration. And then lastly, when it comes to telemetry and monitoring in a cloud native environment, there are many types of solutions that could be leveraged to facilitate monitoring. Typically, we see a lot of architectures that are based on Prometheus as that desired service for collecting metrics and key performance indicators. It provides visibility through a user interface leveraged by Grafana, and of course, alerts and notification provided by Slack, for instance. Now, this could be a very easy way to capture, of course, metrics. And cloud native is all about, again, multiple systems working as one and providing access to all the data that they collect, whether it's the application itself, whether it's the Kubernetes cluster, or whether it's a micro WAF running within the cluster. They all need to report their information to a centralized repository for forensics purposes, and also for AI and machine learning. So we're able to, of course, drive some insight from all that data that we collected. So especially when we take a look at the landscape, we have multiple components in a cloud native environment. We have nodes, we have pods, we have services. We have an architecture that is distributed. We want to be able to reconcile everything and kind of get a sense of how the application is performing. So a single pane of glass or a source where we can, of course, view the traffic, the alerts, notifications, and the system health is critical. And then lastly is the open part, open APIs, and be able to offer access to those attributes collected from all those applications. Now, with that, what I'll go ahead and do with the time we have left, I'll go ahead and, of course, introduce Snapt and what and how we help, of course, in when it comes to application delivery in a cloud-native environment. So a little bit about us. We're a global application services delivery platform. We ensure that your business applications are always on. They're fast and free from threats. We have a centrally managed ADC platform that was built for DevOps teams to deploy and manage and elastically scale all those key functions we've covered: load balancing, web acceleration, application firewalling, and we do that across any environment, across on-premise, across cloud providers, Amazon, Google, Azure, DigitalOcean, and others. And we do that in a very cloud-native fashion. Not only that, of course, technology itself leverages a lot of the components we've covered during this session, but it provides the tools, of course, for automation, automated deployment, as well as gathering telemetry and information that are all visible to you from a centralized location. We've launched Nova in 2019, and we are supporting more than 10,000 users, of course, actively on a daily basis on the platform, and across 60 countries. And if we take a look at our architecture, it combines really the best of both worlds when it comes to the lightweight micro application delivery controller that offers the load balancing, security, and acceleration that could be deployed instantly in a matter of seconds to any environment, whether it's a hypervisor, whether it's a container or an instance running in the cloud, and then provide all those key capabilities, such as the ones described here on the slide, and provide them on top of any application. Provide layer 4 and layer 7 traffic control, and of course fully compatible with container orchestration platforms like Kubernetes and Docker Swarm and others. Now, the benefit of this architecture that we can see here is that it combines a control plane that's separate to the data plane, where effectively micro ADCs can be allocated instantly and simply download their configuration from a centralized console. That centralized console is where you would define what the security settings are. So for instance, if we take a look at a cluster that's running 100 micro WAF instances, and we need to whitelist a rule, we will be able to express that centrally on the cloud controller at the top, and then we will facilitate that propagation of rules directly to the 100 instances you have deployed. On the other side, of course, all the information that we will collect, security threats, whether it's access logs, and of course the performance of your backend applications, they're all reported to the cloud controller, where they can be centrally accessible for your IT administrators. And then at the same time, we offer those integrations for monitoring with solutions like Prometheus, threat intelligence platform combining with AI and machine learning, and of course various types of monitoring tools and access logging capabilities. Now, one of the examples, of course, or case studies with clients that we've implemented in a cloud native environment is an online gaming company that is supporting 100,000 active online users at any point in time, and they specifically needed a solution that will be able to handle the traffic coming into their Kubernetes cluster. They're running multiple nodes, each associated with an IP address, and of course, allocating multiple public IPs was a difficult thing. So leveraging a single virtual IP that is able to perform health checking and route traffic reliably to the individual nodes was a key item for them to really improve how it's being managed. But then also when it came to scale and performance, since they're managing a very high volume number of users on any given point in time, they were also looking for solutions that will be able to meet their demand in terms of scale. And we are able to support 100,000 SSL transactions for them, running in the cloud, along with that single virtual IP address. And leveraging, of course, our native auto-scaling capabilities, the client is also, of course, as we identify uptick in traffic, we're able to deploy additional instances of our load balancers, and web application firewalls. And then when we identify a decrease in traffic, we're able to scale down the environment, of course, to meet that cost saving threshold. Now, the solution is essentially deployed as a droplet, fully managed by a centralized cloud controller that the client, of course, has access to centrally define its configuration and settings through a multi-tenant solution. And the benefits were, of course, a lightweight solution. When you think of a Kubernetes cluster, we think about workloads that are very lightweight and easy to manage. And just to give a point of reference, our micro application delivery controller is about 18 megabytes. And so it's very efficient and can be deployed and incorporated to any container image, as well as, of course, be pulled from the container hub immediately and activated again in matters of seconds. Of course, there's the benefit of that centralized telemetry and collecting the analytics, so they're able to reconcile and understand how the application is performing as a whole, and not just look at the individual services to guarantee that users are getting an adequate experience. And then lastly, when it comes to DevOps, automation is key for those types of platforms, and the fact that we were able to support kind of a native integration through YAML templates to spin up resources on the fly was another key aspect for them. So with that, I'd like to thank you for joining us today. And if you're ready to begin your cloud native journey, and of course you have questions or you would like to speak to one of our specialists around best practices around routing, security, network security, DevOps, and of course telemetry, we're here to help. So feel free to contact us, and happy holidays for everyone. And Gabby, back over to you.
Thank you so much, Simon. It was a fantastic webinar. Happy holidays, everyone. And just to echo what Simon said, should you need to get in touch with either one of us or our team, we're here to assist. I'm looking forward to hearing from you. Have a wonderful day and evening further. Thanks, everyone.